Now it's recording. All right. So back to the bin problem. I'm skipping part A. Did you say we did that yesterday? Where's my cursor? Oh, there he is. Okay. So didn't we? Did y'all say we did part A yesterday? Okay. Well then we did. We have done part A at some point in your life, so I'm not doing part A. Now part B I created on my own. Let's see. So back a recap of this problem. We did this a long time ago, but Ben is riding his unicycle on an east-west track. The twice differentiable function b. Seconds ago. So okay, so we have acceleration. Ben's acceleration is negative. So a of t is negative. I don't think we need that, and I don't think that's even in your paragraph, is it? I think that's something else I went in and added to the question when I altered parts A and added E. So, I'm actually, you know what? I'm not even going to mark that. Ah, where's my cursor again? This is going to be a very bad recording. I can't. Where am I? Oh, there he is. Okay. So I'm gonna. Well, we just won't talk about the acceleration. Table gives values of b and v. Okay. Explain why there must be a value r such that v of r is negative. Somewhere between 0 and 60, your velocity is negative. And I'm telling you it happens. It's not is there a time, it's explain why. So it does happen. How can we verify that the velocity is indeed negative at some point? Okay, that would be a good thought, intermediate value. The problem is with intermediate value, you actually look at the function itself and you want to see something that forces the velocity into negative land. All right. Unfortunately, all my velocity values given are positive, and intermediate value wouldn't work. Right? Huh? What does it say in the problem? Okay. All right. So intermediate value, not a bad thought, but is not going to work. Also, intermediate value is really more for showing that the velocity is something very specific. Like, does the velocity equal 0? If I give you a value, then you'll say, okay, is there a point where the velocity is negative? If so, we go from positive to negative, therefore 0. That's intermediate value. Showing that the velocity is negative, that's kind of a broad explanation or broad goal. So IVT won't work. All right? Any ideas? What if, instead of v of r is negative, I said that b prime, because v is the derivative of b, what if I said b prime is negative? Because that's the same relationship. Does that help you look at and find something in that chart to indicate a negative derivative of b? Yeah, where? Yeah, from 10 to 40, my overall change, I'm going from 136 to 9. I've got to decrease. That is a decreasing, overall decreasing function. So somewhere on that interval, I would have to have a negative velocity. So while I'm not looking for a specific value, but I can use the mean value theorem, right? So because b is continuous and differentiable, remember anytime you use a theorem, you must lay out whatever requirements there are to use the theorem. So b is continuous and differentiable, and we're going to focus on 10 to 40. Therefore, the mean value theorem guarantees that the derivative of b would have to equal b of 40 minus b of 10 over 40 minus 10, which would be, oh crap, I'm going to do this in my head, negative 127 over 30, which is a negative value somewhere for some r on the interval 40 less than r less than 60. Right? So I've shown through the mean value theorem that I must have a value for the velocity, because v is b prime, I must have a value. Now I gave a specific value, negative 127 over 30, but it's negative, and that's all we were trying to show. Are we okay? Did I mess up? Oh, 10 to 40. I looked at the wrong interval. Whoops! There we go, from 10 to 40. I'm about to write it again. Okay, 10 to 40. There we go. Are we good there? Good there? All right, number C. Almost the exact same question. Almost the exact same question, only easier. We're trying to show that the velocity is equal to 2 somewhere on 40 to 60. Right? And again, I would like to use intermediate value theorem, but to use intermediate value, we would need the velocity to dip below 2, and we're looking only on the interval 40 to 60 this time. And the data for intermediate value is inconclusive. So again, we're going to think we need b prime to equal 2, which would be a mean value, and from 40 to 60, the slope is 2. All right, so again, b is continuous and differentiable on the interval 40 to 60. Therefore, b prime of t must equal b of 60 minus b of 40. What did I do wrong? Yes, what is Rolle's theorem? Yeah, that's right. I'm kind of bouncing the question back. I'm getting there. Anybody? The difference between Rolle's and mean? Yes, Rolle's theorem is when you begin and end at the same value, and the conclusion is that the derivative is 0, specifically 0. And so it is mean value theorem, but it's only when the end result is a slope of 0. So you could always use mean value theorem in place of Rolle's. The only reason you need to know what Rolle's is by name is if it happens to be mentioned by name in a question. You got to know what they're talking about, but it is mean value theorem. Some teachers don't even teach Rolle's theorem. They teach only mean value and just say we're doing that all the time. Good, good? Good, good. All right, let's do D. Duty. I'm 41 years old. Okay, D is a good one. Current page, new page. D is a good one because it brings related rates into what does not look like a related rate setup. Okay, so D, and y'all don't have E. If you want practice with linear approximation, you can do part E. Okay, so a light is directly above the western end of the track Ben rides so that his distance from the light satisfies that equation. At what rate is the distance between Ben and the light changing? Okay. Now the of t parts make this a little bit hard for me to read. I don't like the L of t and B of t. I think I'm going to change the equation to just L squared equals 12 squared. I think that's 144 plus b squared. It just looks better to me that way. All right. We are L does represent the distance, and we are trying to find the rate that distance is changing. So we're finding dl dt when t is 40 at t equals 40. Okay, good. By the way, what equation is that? It's the Pythagorean Theorem. So what's happening is Ben's riding his little unicycle here, right? And there's a light up here, and they're measuring the distance between Ben and the light, and 144 is 12 squared, so that light is apparently 12 feet above the ground. So if you want to draw a picture, we can kind of draw the picture based on the equation, which is kind of backwards. We usually write the equation based on the picture. Anyway, so I'm going to need to differentiate this. So 2L dl dt is equal to 0 plus 2b db dt. db db dt. We good? And in the case of Pythagorean theorem, to make the numbers a little bit smaller, you can always divide by 2 and knock out those numbers. Then we start plugging in, and here's a booger. We don't have anything, right? So But we do have a table. I do know that at time 40, B is 9, right? I get that off the table. So B is 9. And B prime would be the velocity, right? So dB dt would equal 2.5. Yeah? And I can plug those in. I still need to find L, which we can get because we are looking at a point in time when B is 9. So L squared equals 144 plus 81, which is 225. L is going to be 15. That's clean. And then now we can plug in and solve. 15 dL dt equals B, which was 9. dB is 2.5. And we'll solve for dL by dividing 9 times 2.5 over 15. I am not about to try to hurt myself solving that, but I will put units in there. Units would be? Very good, meters per second. All right. We good? We good? All right, so we have 1 minute. The free response question Monday, I like the structure of these two on this page. I like the structure of these where you have a table, and if you look back at this, there are questions that are theorem based, so expect a mean value theorem question. Expect a mean value theorem, which was used in both of these, like right here for part D of the first page. Is there a time when the derivative is 3? Oh, that may be, oh, that was actually intermediate. So we have intermediate, mean, expect those. I will throw in a small related rates part. It's not going to be a full-on start to finish related rates, but it'll be something similar to part B on the front, the rate of change of the volume, or part D on the back. And so it's going to look similar to these two. I'm going to go 4 parts probably. Yeah, one question, 4 parts. I'll give you 15 minutes because that's the average that you get on the AP exam. You have 6 questions, you have 90 minutes, so I'll give you 15 minutes, and then we'll do whatever. Right? All right, there is a video to watch. Make sure you watch it. It's on areas of rectangles, which again is base times height, if you forgot. Y'all have a good weekend. No, I will not.